Okay, let's look at section 9.3 where we're going to actually solve exponential equations. And there's just a couple of steps. First thing you want to do is realize that you're trying to solve for x or whatever variable's in there, so we need to isolate it. And then the second step is we want to remove the exponent. Okay, so in the second step we're going to remove the exponent. Remove the exponent. So for instance, if we have x to the 1/3 power, we want to solve for just x. So we're going to have to multiply to get rid of that. And after you solve for x, then we're simply going to check each solution, because sometimes there's solutions that aren't valid. So let's just take a look at the first problem. Number 1 has x raised to the 4/3 power. So let me rewrite this down here if I can. We have x to the 4/3 power equals 16. And notice that this is already written as a rational exponent, 4/3. So to get rid of that, we're going to just simply multiply by the reciprocal exponent. That would be the 3/4 power. And we're going to do the same to both sides. So we're going to raise 16 to the 3/4 power. So notice that when you multiply on the left-hand side here, you're going to distribute 3/4 to 4/3, so you would get 12 over 12, which is x to the first power. So that's exactly what you desire. And then to rewrite the right-hand side, the index for the radical is going to be 4, and the radicand is 16. And then after we find that solution, we're then going to raise it to the 3rd power. And notice here that when the index is even, whether it's the square root, the 4th root, the 6th root, or the 8th root, when the index ends up being even, we're going to end up with a positive and a minus solution. And the reason that's true is because if you have, say for instance, if you have -8 and you square it, it's equal to 64. And if you have a +8 and you square it, it's also equal to positive 64. So anytime you have an even root, then we're going to have a plus and a minus. So we have plus and minus 2 cubed, and of course that's just x equals plus 8 and x equals a -8. Okay, so let's go to the third step, or fourth step, which is to check each solution to make sure that it's correct. So we're just simply going to plug that back into the original. So let's see, we'll do it in red. So let's check out the +8. So if we put in a -8, the index is going to be 3. And we're going to take that and raise it to the 4th power. And we're checking to see if that's equal to 16. Well, you can, we're checking a -8 first. So what is the cube root of -8? That's simply a -2. And then if you raise that to the 4th power, that would of course equal positive 16. So that one checks out. And now let's go check the positive one. Same situation, right? You have 8 to the 3rd root of that, and then we're going to raise it to the 4th power and check to see if it equals 16. And of course it's 2 to the 4th, and that does equal 16. So this one checked out. The negative case checked out. So the answer is plus and minus 8. Okay, let's take a look at the next one here. The next one is 4x to the 3/4, and just wanted to point something out here, that 4 is the leading coefficient there is not raised to the 3/4 power. So the first step we're going to do is divide both sides by 4. And when we do that, we have 108 divided by 4, which of course equals 27. So we have x to the 3/4 power is equal to 27. And then, sorry about that, let's see if I can rewrite that. X to the 3/4 power. To get rid of that fractional exponent, we're going to multiply by the 4/3 power, and we're going to do it to both sides. And we see that, of course, our x cancels out, and we just get x equals, and rewriting in radical form, we're looking for the cube root of 27 raised to the 4th power. Now, notice here the difference between number 1 and number 2. This index here is odd. So the fact that that's odd, we can only have either a positive or a negative answer. So in this case, in fact, it's going to be a positive 3. So let me continue right over here. We have x equals 3 raised to the 4th power. And of course that would equal 3 times 3 is 9, times 3 is 27, times another 3 is 81. So x equals 81. And let's go ahead and check our answer. Plugging it in over here, let's see, we have 81 times 4, and 81 is raised to the 3/4 power, and we're going to see if that's equal to 108. And of course we could divide by 4, but I think we won't this time. I think we'll just keep this as 4, and then we'll radicalize this, put this 81 to the 4th root, and just raise this quantity to the 3rd power and see if it equals 108. And let's see, we know that this is equal to 9 times 9, and then of course 9 is broken down into 3 and 3. So the cube root of that, of course, is 3. Or excuse me, the 4th root is 3. So we have 3 to the 3rd power times 4, and it should equal 108. So we have 27, that's 3 to the 3rd power, multiplied by 4, and we could check that with our calculator, but it does in fact equal 108. So the answer is just positive 81. Alright, well, let's take a look at number 3. So our solution here is 81. Okay, let me give myself some space here. And okay, so we have 3x to the 1/2 power plus 6 equals 0. I'd like to point this out to you that in this problem, the 3 and the x are being raised to the 1/2 power, or the square root of 3x. So we can't divide out by 3, but we can try to isolate it as best we can. So let's go ahead and do that here. So we have 3x to the 1/2 power, or the square root. Now, how do we get 6 by itself? We're going to subtract 6, and 0 subtract 6, of course, gives us a negative 6. And then we will raise it to we'll square it, right? Because the index is understood to be 2 in the square root. And then, of course, we're going to square the right-hand side. And you square a square root, and you just get the radicand out. So you get 3x equals positive 36. And divide that by 3. And x equals 12. So let's check this answer and see if it's true or not. So we have 3 times 12 and we're going to take the square root of that, add 6 to it, and see if that's equal to 0. So 3x times 12 is 36, and so we have the square root of 36, because remember that's the 1/2 power, plus 6 equals 0, and 6 plus 6 certainly does not equal 0. You end up with 12 equals 0, which is not true. So we'll just simply put up here that there's no solution. No solution on this one. Okay, very good. Alright, let's take a look at our final example in these notes. Example number 4. And we'll see what we get. Alright. Okay, so once again our exponent, or excuse me, our variable is buried inside of everything to the 3/2 power. So let's try to get everything as isolated as possible. So first step is to subtract 1. Subtract 1 from negative 23 and you get a negative 24. And then we have a negative 3 to the 2x minus 1 to the 3/2 power. And that's not a very good 3/2, sorry about that. We're going to divide through by negative 3. Divide to the right side by negative 3. And we're going to end up with 2x minus 1 raised to the positive 3/2 power. And 24, negative 24 divided by negative 3, of course, is a positive 8. And let's go ahead and switch colors up. And now we have to get rid of that exponent, so we're going to raise both sides to the 2/3 power. That's a very bad 3, sorry about that. Try that again. Try that one again. To the 2/3 power. Okay. Of course, the same thing's happening on the left. When you distribute 2 to 3, you get 6. And when you distribute the denominators, you get 6. So 6 over 6 equals 1. And so the exponent is gone. So we have 2x minus 1 is equal to, and over here we'll go ahead and put the index, put it in radical form. And you should be getting pretty good at these because it seems like this number keeps popping up over and over. The cube root of 8, of course, is only a positive 2 because that's an odd root. Okay, remember, it's an odd root, and you're only going to have either a positive or a negative answer right there. So we have 2 squared is equal to 2x minus 1. And of course that's 4 equals 2x minus 1. Add 1 to both sides. You get 5. So come over here and finish the problem off. 2x equals 5. So x is equal to 5 divided by 2. And that we need to check. So since I'm running out of space, I'll just do it right here in the middle. Let's see what we have here. Do it in black. And we have a negative 3 times 2 times 5/2 minus 1 raised to the 3/2 plus 1. And let's see if that in fact equals a negative 23. So this is being multiplied here in the middle. 2 times 5 is 10. 10 divided by 2 is 5. So we have 5 minus 1 on the inside. This quantity, this quantity right here. What did we say it was? 4, right? So we have 4 to the 3/2 power, so that's the square root of that, raised to the 3rd power, and then we got to multiply it by a negative 3 and add 1, and we're still seeing if it's equal to negative 23. Of course, the square root of 4 is 2. So we have 2 cubed. We still have to multiply that by negative 3. Add 1 to it and see what we get. Okay, 2 cubed right here is 8. 8 times a negative 3 is a negative 24. So we have negative 24 plus 1, and it does in fact equal negative 23. So we'll go ahead and record our answer in the box here. Our answer is 5/2 or 2.5. Okay, hope you enjoyed this video and should help you with your homework.